I start, uh, first of all, good morning and welcome to the third Mikrotik user meeting. And I hope everyone is enjoying the morning. First of all, let me introduce myself. My name is Dan Santillan. I'm the owner of Cygnal Technologies. Anyway, before I start, I think introduction is needed right now. Cygnal Technologies was established in the Middle East back in 1997 to 2003 under the name Cygnal and PCTech. And we do provide internet dial-up and visit provider for military service contractors. Established in the Philippines in 2003, and we are also a registered internet service provider. We've been using Mikrotik since late 1999 to present, and these are our services. Let's move on. Before I start my presentation, let me give you the background of this presentation and the topic it will cover. What I will present to you is the use of bridge interface. I don't know if a lot of you are familiar with the bridge interface. Most of you would probably, thinking of bridge interface as to bind all those physical ports. I will focus more on the layer 2 filtering along with the Mangle facility. In Mikrotik Mangle, layer 2 field is very limited, and sometimes getting a specific hits of the packets is difficult, especially in a VLAN environment. So who can benefit from this? If you have deployed a lot of network infrastructure, an existing one, and you need to have a plug-and-play bandwidth management without any changes or without making any changes to your network, and this is for you. Now, let's say we have a scenario like this. The ISP allocated the network with a small public IP, and all public IP must be assigned to the routers, and clients should not be NATed. The network router is a non-Mikrotik router with its own proprietary services. Have you experienced a router in a network and you cannot replace it? Have you? Okay, this one is for you. All right. Workstation has a specific route provided by the non-Mikrotik router to reach other devices on the remote side. This is the scenario. Basically, what it's telling us is do not touch the network. Have you experienced adding a bandwidth management to an existing network without even touching it? Anybody? All right. Now, the task is provide a scalable bandwidth management for each network, not to replace the existing core router, not to make any changes to the current infrastructure, IP addressing, routing, firewall, etc. A minimal downtime of less than a minute to provide hotspot, and a provision for NATed LAN. So have you ever experienced, any of you, facing with a client and telling you they want a bandwidth management, but don't touch their network? Or don't touch the router, not to change it? Have you? Who experienced it? You did. All right. Now, the possible solution that I come up that you would think is replace the current router with Mikrotik. Right? You would think, I need a bandwidth management. Let's change your router. The problem is it's not possible because it will break all the proprietary services, connectivity, and securities. Okay, so changing the router with the Mikrotik is not possible. So how can you do it, right? So let's see what the solution could be. Add a Mikrotik router just right after the fiber modem. And make it transparent. Okay? And I will explain to you later how this thing can be done. Now, the question is, what mode should we use? A router mode or a bridge mode? What would you do? Bridge mode, right? If you do a bridge mode, how can you control the bandwidth? Remember, one of the requirement is not to change anything on the network. So if you do a bridge mode, okay, you can no longer control the bandwidth because now all the IP addresses are belong to the client, to the other remote router, okay? So there is what I call a transparent bandwidth controller. It's an inline. So basically what it is that you will design Mikrotik, put it in there, plug and play, don't touch anything. Interesting? Okay, I know. Now, I will demonstrate to you how this can be done. But before that, we need to understand what is an inline devices is. What is an inline device? A device that can be installed between two or more network devices that can perform specific functions. It receives the packet and forwards them to an intended destination, blah, blah, blah. All right, moving on. It operates at layer 2. If you still know your OSI, that's where it operates, and also with layer 3. It is transparent, and end devices are not aware of its presence. Can you give me an example of inline devices? Anybody? Anybody? That guy said, oh. Okay. Well, there are two types of inline devices. The non-intrusive. Wait. There you go. This thing. Excuse me. I lost it. Okay, there you go. Thank you. So the non-intrusive inline devices, and this is the one of the most common inline devices that you have used. This is a coupler, that is to extend cable length. Another one is surge protector, okay? Another one is PoE. These devices are called inline devices. You attach them, they don't modify their data. It's like it's not there, but it provides you the capability, or these devices, like for example the PoE, it gives you the power. Surge protector, it protects your Ethernet port. Then there is also the intrusive inline devices. Can you give me an example of intrusive inline devices? Anybody? Network guys, anybody? Okay. Network sniffer taps. This device is commonly used or normally used by the hackers or to troubleshoot your packets. So you connect one end to that device, and whatever goes there will be mirrored to the middle one. All right? And then there are types like appliance bandwidth controller. This device, you will just connect them to your network, and it will optimize your bandwidth transparently. Now, I will focus more on Exinda because it's very interesting. Exinda is an one optimization appliance. It can control the traffic at the layer 2 and above. It's an application accelerator, application visibility. It means your software should be able to see the other side. Like you have two set of systems and you put the Exinda in the middle, it can still see the other side, all right? Monitoring, reporting, and can be set as in inline network devices. It is effectively used in a slow network such as the VSAT system. Are you familiar with the VSAT? Anybody here familiar with the VSAT? VSAT basically is an internet via satellite. The problem is it's very, very expensive. The bandwidth is very slow, high latency, and it costs thousands of dollars. So most providers use Exinda to connect their satellite to your network. And the price is based on the one bandwidth. So if you have a 2 Mbps one, that will cost you $1,000. If you need more, it'll cost you $6,000. All right? So I'll tell a story about this rural tech development in Papua New Guinea. Rural Tech invited me to Papua New Guinea to do a project, and it involves VSAT installation. And this was last month only. And RTD uses a lot of Mikrotik devices for their remote site deployment. And since they use VSAT, the latency is very high, and to compensate, they use Exinda. They're so expensive, and the operator wishes to have an alternative for the Exinda. So Shas, the owner of RTD in Papua New Guinea, wants me to turn Mikrotik to function like similar to Exinda. Okay, so you can find on the internet what Exinda does. And over a cup of coffee, we discussed a lot of things on how he wanted this bandwidth management, similar to Exinda, be done to the Mikrotik. And by the way, they are hiring right now, so they need 2 Mikrotik engineers. I'm serious. So if you want the opportunity, just visit my booth, and I'll give you the details, okay? For those who are practicing Mikrotik, this is a good opportunity because they will send you to the mountain. No, seriously. They will send you to the mountain. You got to ride a plane and a helicopter just to reach there. And it pays really good. You will learn how to install satellite, those big boys' toys. Well, anyway, moving on. So let's make Mikrotik to function like Exinda. Before I start, let me remind you that Mikrotik Wiki has an entry for this. They have already the transparent bridging at the wiki, and you can compare the method that they use and the method that I will use. Now, there are only 3 steps. Attach the port to the bridge, create a bridge filter, and create the bandwidth limit. All right? Again, there's already a transparent traffic shaper entry at the Mikrotik Wiki. So you'll just search it and you'll find it. Now the difference is, I use a different approach. The Mikrotik Wiki is a method where you will use the Mangle facility. All right? The problem with the Mangle facility, it lacks of layer 2. The only layer 2 that you'll find there is the MAC address, and that's it. So if you want to If you want to filter more on the layer 2, like the VLAN ID, the ARP code, the STP codes, you won't find that with the Mangle. Instead, you will find that on the bridge. Now, just a comparison. In the wiki, the method is the packet gets into the bridge, go to the mangle, go to the queue, and the bridge out. So there is no layer 2 right there. It's only pure layer 3 all the way to 7. And on my method, it covers from layer 2 to layer 7. So you can see the red-orange color, the bridge filter, the mangle, and the firewall filter. My approach, it does give us the option to use all the available layer 2 fields. In other words, if you want to filter something from the layer 2 and match it with the mangle, with the layer 3 or layer 4 or whatever, then you can specifically tell Mikrotik, this is the packet that I want. So it is more precise, it's more effective, and it's more what do you call that? Never mind. It's on the top of my tongue, my head. So let's go to the configuration, setting up the bridge. As usual, you have to bridge 4 ports. 1 for the ISP, 2 for the routers, and 1 port reserved for later use. I want you to remember that, okay? And we'll do something about it later. So the command is very simple, just like that. All right? Now, next is to create the builder, to create the bridge filter. What we need to do here is we need to identify the in and out interface. So it's gonna be a one-way direction only, and we must be very, very particular about this. All right? So the direction is from ISP to router 1, and that is a command. You do the same thing with the upload part, all right? And you do the rest with the R2. Now, limiting the bandwidth is very easy with Mikrotik. We can use simple queue or the more complex Q3, but in this demonstration, I will just use simple queue for simplicity purpose. So we will be using 2 rules for each network, 1 for the downstream and 1 for the upstream. It gives us more control, okay? So with the limit download, have you noticed the limit at and the max at? It sets to 0. Okay, that is the upload part. We don't care about the upload part because we only care about the download part. So we set them to 0. Then reversed with the upload, we don't care about the download, we only care about the upload. And you do the rest. So there's only like 4 commands depending on how many routers you have. Now, here is the result. And you tell me if you have noticed anything. So, what did you notice? Can anybody tell me what did you notice with this system? Anyone? Anyone? How about you, sir? Did you notice anything? Mikrotik guys, yes. Which one? Almost. Anyone else? All right. You didn't see it? Okay. You see that? And you see the other side? The router doesn't have an IP address. It doesn't even have the route, but it controls the bandwidth. Right? You didn't notice that? How about you, ma'am? Did you notice it? No? All right. So you see, we can control the bandwidth by not using IP address, but by using a bridge. But of course, you have to do a different approach with the system. All right? Next, we will discuss about the firewall. Typically, when you use firewall with a Mikrotik, your Mikrotik needs to be the gateway. Am I correct? Am I correct? Because most of the firewall, you will scan the packets and look for a certain fields like port, destination, layer 7, things like that. But in order for that to happen, your Mikrotik needs to be the gateway. So let's read what the bridge firewall is all about with the Mikrotik and how can we use them. Based on the wiki, it says the bridge firewall implements packet filtering and thereby provide security functions that are used to manage data flow to and from the bridge. Now, I want you to focus on the second sentence, second paragraph. You can put packet marks in the bridge firewall, which are the same as the packet mark in IP firewall, i.e. referring to your mangle or to the firewall filter. Okay? You can do that with the firewall bridge. So basically, this is what will gonna happen. You have the bridge, you do the packet marking over there, and send it to mangle. If you need some more information to extract, further processing, and you can send it back to the firewall filter, either to allow or to block. Or you can do it via the bridge and directly to the firewall. This is the firewall on the bridge, using the bridge as your firewall packet filtering. Typically, this is what you do. You do the mangle, send it to bridge, and drop it. Okay, this is what you normally do. Or filter it on the bridge filter and drop it from there. So with Mikrotik, there are so many ways to filter packets, and most of it are based on layer 3 and above. So if you want to filter layer 2, well, you got to do that with the bridge, otherwise. Now, the common approach is the IP firewall filter, protocol-based filter, mangle, or the firewall filter, DNS or proxy redirection, layer 7 matcher, etc., etc. These approaches are mostly based on layer 3. And I'm sure you're familiar with that, right? Okay. It requires that the Mikrotik device must be the gateway in order for this filter to work. Otherwise, it won't. Okay? Our Mikrotik inline shaper does not act as a gateway. Therefore, it doesn't need to have an IP assigned addresses or any running services. So you have a unit, nothing in there except the bridge and few lines of codes. All right. If you'll think about it, you would think, oh, okay, this is very complex thing. So there's actually 2 steps configuration. Mark the packet at the mangle facility, create a bridge filter, and do the filtering. Here is a demonstration of filtering packets on bridge and mangle facility. Okay, so that's the design. Look at the direction. Be very particular about this. You got that? Okay. So from the mangle, we mark the packet, send it to the bridge, and you just do your magic over there. Filter them out, and there you go. Very simple. 2 lines of codes, right? And remember, still we don't have IP addresses on the Mikrotik. There's no gateway, there's no protocol, there's no IP address at all. And here is the demonstration on that. Filter turned off. As you can see, the email passes through, all right? And yet, address list is empty, route is empty, but it goes through. So we turned it on. There you go. Okay, there you go. So, isn't that magic? Really magic, really. So what L2 fields can be used for packet matcher under the bridge filter? Now, number 3, number 2, 3, and 4, you cannot find that in the manual. You can find that with the bridge filter. Like, for example, the VLAN ID. So if you have a case of you want to control a certain VLAN ID and shape it or control the bandwidth, you don't use the interface attached to it because our system is totally transparent. Okay? You can do that with your bridge filter. Now, if we use all of this for boxes and we add a manual rule to cover layer 3 to layer 7, what you will have is a better chance to hit a specific packets. Imagine a scenario where you want to mark VLAN ID 100 with a certain content on a packet, then you have a better chance of filtering it. Now, what to do with an unused port? I will just cover the basic LAN and WAN. I won't be covering the hotspot configuration here because that will take more time. So what to do with the unused port? The 2 port, we will bind it as for our LAN. Because if you will look back at here, you would think, well, we don't have an IP address on the Mikrotik, right? So how can we use it? How can we use the remaining ports if this is only a transparent? And yet, we want to have our own LAN on the same unit. So that is for the LAN. Hotspot access port. And then we will use that last port as the one of the 2. So imagine a Mikrotik having 2 routers in it, okay? It's like 2 separate segments. Now, almost done there. So remember the reserve ports? Okay, that port is a member of the inline bridge, and it should not have any public IP. It's part of the R1 and the R2 and the ISP. So there should be no IP on that port. And you can attach another router to that port to expand the network. All right? So that's the most important thing. So yeah, you can attach a new router. Although it is okay to add an IP to that particular interface, we are trying to avoid it because we want our bridge to act like a managed switch. Okay, so it's a plug and play. So what are you going to do with it? If I would ask you, what would be your approach? Rocky? We discussed this at the office. Okay, so anyone? Anyone? Okay. Well, the very simple trick is just use a patch cord. Connect that to the one side, and that's it. The one side will act as a normal router only, and the reserve port will act as like a switch. Very simple. Did you get it? All right. And this is the LAN and the WAN configuration, and it's very simple. It's very basic. I'm just telling you how it is done. Okay. So this topic is the. I had this client who requires the same service, the same bandwidth management. They already have an existing network, and they are using the most expensive phone network like Cisco and Juniper, things like that. And problem is the bandwidth management from the ISP is not really built in with the Cisco or with the high-end machines. But they have special functions though, like securities and VPNs and things like that. So Mikrotik as the inline bandwidth traffic shaper, okay, solves the problem. So maybe you will encounter something like this, okay? Even if you know, just using it for home-based only, or if you're operating an internet, or if you're a mini WISP or a mini ISP, you can do all this. So it's very you know easy to make. You only need like 5-8 lines of codes and make your Mikrotik an inline traffic shaper, and also a UTM using the firewall, where you can mix and match between layer 2 and the mangle to cover the layer 3 and all the way to layer 7. Okay? Well, that's all for me right now. Thank you, and I hope you enjoyed my presentation.
Do anybody has any questions for presenter?
Yeah, Louis will be presenting.
No questions. Thanks, Dan.
Oh, thanks, Edmund. Thanks, Dan. Thank you. Kailan bigger?
May HDMI naman.
Ha?
May HDMI.
Naman.
Meron ka HDMI? Oo, HDMI.
Next presentation will be from Archel Wui from Databyte Computers.